This is problem 4.3.11 from the book. In this problem, we're given the derivative of a function, and we're given that that derivative is x to the negative 1/3 times x plus 2. And the first thing they want us to do is find the critical points. So I'm going to rewrite this derivative as x plus 2 over x to the 1/3. So now it's pretty easy to see that our function is going to be undefined when x to the 1/3 equals 0, which happens when x equals 0, and our function is going to equal 0 when x plus 2 equals 0, which happens when x equals negative 2. So now we know that simply that our critical points occur at 0 and negative 2. So we have x equals 0, x equals negative 2. Negative. So now let's see what that tells us about the function in regards to when it's increasing and decreasing. So let's consider some points around 0 and negative 2. Let's take negative 8, negative 1, and 1 because they're just easy to find. So let's plug them back in. So f prime of negative 8 is negative 8 to the negative 1/3 negative 8 plus 2. And we can see that this is going to give us a negative number and this is going to give us a negative number. So that's going to yield a positive. So it's positive on this range. Then let's see what's happening at negative 1. Negative 1 to the negative 1/3, negative 1 plus 2. So this is going to give us a negative value, and this is going to give us a positive value. So a net overall negative value on this range. And at 1, we have 1 to the negative 1/3, and we have 1 plus 2. This is going to give us a negative value, this is going to give us positive, or this is going to give us a positive value, this is going to give us a positive value, and that's going to give us a net positive value. So now from our little chart here, we can see that for part B, from negative infinity to negative 2, and from 0 to infinity, our function is increasing. And from negative 2 to 0, our function is decreasing. And we can use that information to identify our local min and max values. So at negative 2, you can see that we're going from increasing to decreasing, which means that negative 2 is a local max. And at 0, you can see that we're going from decreasing to increasing. So at x equals 0, we have a local